Thanks a lot for the kind introduction from Babel. It's a great honor for me to be here because I heard the University of Applied Art Vienna a long time, and a lot of my friends actually teaching in your school from Europe, from the States. Last night I talked to Carl Chu, who is very early invited actually by Jaha to make a review in her studio almost 10 years ago. So it's a very good reputation from your school to organize the advanced and the pioneer research in your studio. So today, shall I share my screen right now? Mm-hmm. It's okay, you can see my screen?
Yes.
Yes, thanks.
Okay. So the topic today I want to put forward is a digital fabrication towards the material intelligence. So every year we organize special event, Digital Futures. So this year, the topic of the Digital Futures will be the material intelligence. So it's a time to talk about, based on the artificial intelligence, based on a lot of advanced technology outside the discipline of architecture. Actually, we introduce a lot of the technology outside of a discipline into the architecture, our research and practice. And the digital fabrication actually is what we make research in the past 10 years. So that is some integration and to introduce what we're doing right now here in Shanghai. And it will be a great honor to introduce the research and practice in our daily life. So here is the place I'm making that lecture, which is my studio, very close to Tongji campus in Shanghai. So it's around 12, 13 years ago, actually, we find this special place, which is an undeveloped area in China and the warehouse. So we make some research to try to set up our research base in this venue. So we make this brick wall at that time we name it silk wall, actually, which based on the parametric modeling process, but actually we implement very low budget material, this kind of brick, which is like €1, you can buy 3-4 pieces. It's a very low-tech material, but based on the different implementation, we designed this wall to showing our attitude to the future. It's low-cost material, but actually the aesthetics performance goes to some new criteria, which give us some understanding of the future architecture. And this is our courtyard, and actually we have this like a three-span warehouse. 15 years ago, I founded Archi-Union Architects in Shanghai, and the environment of the office is kind of representation of our understanding about how we could set up the relationship between us and the Shanghai urban culture. As ivy growing in the outer courtyard of the office, we progressively making our dream through the expansion of the physical space. So you can see the bamboo actually is growing, growing outside of the silk wall. It's like a new relationship between the man-made object and the nature. And the garden is actually embracing the office, and the office also embracing the courtyard greenery. In ancient China, garden is not only the physical space for leisure behaviors, but also the dream space, reflecting the holistic view towards the harmony of body and nature. Ji Cheng, a gardener in Ming Dynasty, in his book Yuan proposed concepts such as borrowing screens and being adapted to the local artificial conditions, which are actually a representation of the holistic view on human and nature. And here is a project I want to introduce. 2 years ago in 2019, I was invited by the curator Luca Molinani, who is the chief curator of Milano Triennale several years ago. He curated a special exhibition in Suzhou Garden, which is the master of net garden, the most famous one in Suzhou, which is almost not the largest, but one of the most representative. A Metropolitan Museum in New York City also collect this garden named as Mingxuan, which which located the second floor of the Metropolitan Museum. And we actually invite to design a special object, a special pavilion on object inside this garden, but which is super difficult as you're understanding, because how to make a dialogue with the tradition. So here is a very special scenery. In this view, we can see three different rockeries from three different time periods. The middle one is actually the natural format, Taihu rockery, from the Ming Dynasty, almost like 500 years ago. And the upper one is an artificial craft stone made in the period of Republic of China, around 150 years ago. The lower one is our exhibition project, which we use recycled plastic, implement the robotics to print it, be involved into the continuous making progress of the garden. We would like to propose a contemporary view on the relationship between the artificial and natural, but still it's like every different time period, we like the relationship between the stone, which is a rockery in the garden, but actually the material, how to make it, and the attitude is changed. In the exhibition process, we can see the visitors actually, they're very curious on this special object and sitting on it, lying on it, but actually the recycled plastic, which gave a special opportunity to rethinking, set up some new relationship between the tradition and the culture and the future, the new technology and the tradition. So that is probably I wanted to introduce the attitude from our practice. Actually, we embracing the new technology, but at the same time, we make a special aesthetic performance, which have a special perspective from the cultural perspective. And here is a tea house. I'm making the lecture. I'm right now sitting on the first floor, and which is located in the backyard of Archi-Union office, which is constructed from the salvage part of the original warehouse, collapsed roof. The site was extremely constricted with walls on three sides, and with only one side facing towards an opening space that contains a pool with a further restriction from the nature tree. And the design tries to embody the harmony by integrating the enclosure and openness, delightful space and logic construction and other complicated relations. The building reacts to the site environment, and the main object in the tea house is a stair, which maximizes the amount of the space and leading you to take different experience to the tree. So it's like first floor is a trunk, and the second floor, if you're going up through the stairs, you can figure out your relationship to the tree. So this is the ground floor. We're drinking tea here. And the second floor is like the trunks and the branches and the shadow of the leaves. So we're sitting at the shadow of the leaves, and which is a library space here, and make readings. And in the back second floor, we also have a small courtyard, which increasing, we can see the leaves which are falling down from the roof and to the very small balcony. So it's like three looks on the same tree, which showing our attitude, not only on object itself as a geometry space, but also which set up a special relationship between our human and the environment, a tree. So that is a dialogue to the nature through a special object in between the nature and the human. So here I want to introduce Michael Pondy actually describes the tools becomes very important through different perspective. Actually, every year we invited different philosophers to our Digital Futures to make a lecture. 3 years ago, we invited Andy Clark to come to Shanghai, and who is famous for his theory, the natural-born cybers. And in his lecture, I still remember, it is perhaps, he mentioned our human nature is to adapt the new tools so that they can become our prosthesis due to the plasticity of human brain, new technology could be contained, absorbed within our body screens and becomes an extension of our body. So that is some special, interesting philosophy we want to introduce, and based on our understanding between the human and the nature. So right now, after the Andy putting forward extension of our human body, we need to find out new relationship between the tools and how to change the world, change the nature through different kind of tools. So that is about Mandy Merleau-Ponty describes the tools becomes incorporated into the extended body schema as a kind of prosthetic bodily extent that allowed us to experience the world through it. So what's the difference between the prosthetic hand and the human hand? Could data flow be able to deliver the human emotions and perspectivity? And here is the in-house robot yard in our office. So that is very special to the design office. We have like a special partner sitting at the corner of our office, because we implement a lot different kind of experimental research on this platform. The Gantry Robotic Factory was set up in 2015, around 6 years ago, which spent us almost 3 years to settle down everything and follow the dream of the fabricating future. We developed actually the heart of the future robotic factory inside the design studio. The range of our work is not only limited in the model scale, moreover, we focus on the one-to-one mockup and the real building scale as well. On this platform, we developed like 3 different kinds of new crafts, including the robotic timber structure, 3D printing, welding, etc. So you can see our very interesting background. We have a special attitude, a very tradition between the nature and the human. We're trying to create a different kind of geometry space. But at the same time, we focus a lot on this kind of expanding tools like robotics as a partner to the design office. So that is like a quite mixed style between the technology and our philosophy. So that is, I want to introduce at the very beginning of this lecture. So this is also including some in-situ robotic platform, different generation. So this year we developed actually the 9th generation. So every year is like from 2017, we have 1 to 2 generation we develop and to introduce this platform into the construction process. So actually, this is another platform we developed to control all the robotics, which is FE-Robot. You can download it very easily from the Rhino Footfall, which is like open source to all the users. And we want to make this, set up this kind of sharing culture to introduce all the tools we make research, and which is also collaborating with DigitalFUTURES workshops and try to introduce all this kind of toolbox to the design process. So this is FE-Robot, which is the robotic visual simulation and control operation platform for the architecture construction industry. You can scan this right FE-Robot website, and which easily can introduce this platform to all the users. And the goals for the FE-Robot is seamlessly involve the architecture geometry into the fabrication process of construction robotics. So as a platform of Rhino Grasshopper, FE-Robot can efficiently realize KUKA ABB UR. Right now we have some two local brands from China also participate to the team. So which is set up a different robotic two-pass planning and real-time feedback and control tools. And most importantly, I think FE-Robot set up a kind of culture of learning, sharing, and collaborating, because when we open our platform to the users, and the users also can upload their tools onto this platform, so we can learn from each other. So the scenarios is expanding very fast in the past few years based on FE-Robot. So also you are welcome if you want to make research on robotics, welcome to download FE-Robot to make use of this platform. So we can see this is different kind of brand, and based on the digital twin and different kind of .src.mod that script showing different kind of brand of platform, different robotics can be easily transformed, change their information seamlessly based on this platform. In 2019, I was invited to teach in UVA. I bring this platform, FE-Robot, to UVA and help them to set up the timber structure robotic lab. So we introduce different kind of tools as a plugin, including bandsaw, chainsaw, circle saw, drilling machine. So which is like software, hardware collaborating platform, which is globally could be set up based on this software. So it's like very easy. We spent around 6 years to make research on it, but I spent only half a year to teach them to set up this lab super efficiently. So that is a global culture we want to introduce to you, what we're doing right now. So based on that platform, not only the software, but also the hardware, so how we integrate this kind of technology into the teaching process. This is the 3 bridges in my studio, actually 2017 to 2019. I want to introduce, this is undergraduate year 4 studio, robotic experimental fabrication. So the first year, we use 3D plastic printing technology, which is a recycled plastic PLA, to print 2 bridges, actually, which is located in our school. This is a process, and we totally embracing different kind of platform, including kangaroo, to generate the curvature of the bridge, double layer, because we want to print efficiently the plastic between this two circle and two curvature form. And then we use Millipad, which is finite element optimization software to reduce the weight and save the material process, to find to translate the structure forces to some printing toolpaths. So that is the second process to doing this. And afterwards, we just directly printing the forces and to generate the form of the bridge. You can see we have 1 robotic printing and also 2 robotic and printing 2 different components differently and super efficient. So 3 robotics printing 320 hours for the whole bridge. This is Patrick Schumacher from Shanghai to participate in the opening of the event and standing on it. And the first year, actually, which is the chief secretary of Chinese Architect Society, he asked me how many people are standing on it. I told him, under the very careful calculation, it's very safe to standing 5 people on it. So he said, okay, we invited 5 people and we're standing on the top of it. Everyone is a little scared, but it's okay, we're standing safely. But after 45 days, because the summer of Shanghai is extremely hot, so the bridge was collapsed because of the very hot temperature. On the top of it is around 70 centigrade, and the under part of it is around like 40 degree. So the temperature difference make it extremely hard pressure on the top and on the bottom because of the very hot temperature. So the bridge was broken. So we test to failure in this bridge, making it so the bridge only existing on campus for 45 days. This is first year. And the second year, we try different, introduce another technology, 3D metal welding. So this is like, you can see we have 7 people sitting on it. Standing on it, including Yuan from MIT and also Wang Shu coming to join us in the opening. You can see the process, how we translate this kind of optimization, structure performance-based design, and try to printing them, welding them point by point to make the bridge based on this kind of thing. So, and Wang Shu is very interesting in this kind of details. So, which is 2018, I think it's like 3-4 years ago. And I think this kind of crafts is very interesting. It's not human crafts, it's machine crafts. But you can see the quality of it is not purely polished, it's like the handmade crafts. So I told Wang Shu it's machine crafts, but you can see the beauty of this kind of process making based on the technology of the robotic printing technology. And you can see the third year, also the opening is same to the Digital Future events. We can stand in like 20 people on it. And the weight of it is only half compared to the first year. So half weight, but the people can stand in like 3 times, 4 times compared to the first year. So I think the technology help us to update the version of our technology and the performance of the structure. We can save the weight and make it more efficient based on the material performance, but which is totally fabricated by the robotics. So this is a video showing the process, how we improve this bridge, design bridge, printed bridge. So 20 days for design. So, which is a very compact optimization process based on the formation of the LIBA, which is developed by Yuan technology. And also we introduce plastic, carbon fiber making the handrails and the stairs, because that is extremely light and high performance. This kind of formation cannot easily construct it. So only way is 3D printing. So we introduce the structure performance optimization process into the design. And we use the simulation technology and also testing this kind of 3D printing, welding technology to making the skeleton of the structure. So this is a simulation process. The simulation is not only on a computer, but the simulation which is a collaboration between robotics and our students. Glass fiber and carbon fiber. So we developed this special machine by ourselves. And this is a real process by this machine. This is an assembly process in 7 days. Okay, so everything is actually done by the students, including 1 PhD candidate and 3 graduate students and 6 undergraduate students. So it's a process with testing how to collaborating between different disciplines, also different students. Actually, the PhD students, mostly they develop the toolbox And the grad students, they can help to organize the simulation and optimization process. And the undergrad students, actually, they're very interesting to open their special vision in learning how to make a design. So it's very welcome by the students in Tongji. I think it's very special cross-discipline teaching experience for me in the past few years. So you can see the new beauty, actually, maybe it's not very high accurate because everything is like the crafts is by the students. It's not like a production from the industry, but you can see this kind of beauty which lies in the making process of based on the simulation, optimization, fabrication, which embracing different kind of toolbox into our architecture design process. And the process is interesting. We try to set up like a culture of which based on the laboratory of design research. And we testing a lot to failure, including the first year bridge actually was just broken. But I think the design credibility and the authorship is actually setting up not only by the result and the form we produce, but also which lies in the process we develop. So that is what we're doing right now here in Shanghai. And try to introduce not only this kind of 3D printing technology, but also we implement in different kind of crafts, different scenarios, which embracing not only the new material like carbon fiber, but also some traditional material like the brick mentioned. So this is 3 projects I bring to Chicago in 2017 to Chicago Biennale. And right 2 project models and videos was collected by MoMA, Yuan MoMA, right now, including these 2 models. And the curator is Mark Lee, who is right now the chair of Harvard GSD, who is a chief curator, and he makes some comments. He told me, when I invite you, Philip, I don't notice everything is made by robotics because it looks quite natural, is contemporary, but embracing the local culture. But after I make the presentation, you can see everything is actually special fabricated by the collaboration between the human and the machine. So that is a special, not only the beauty of the aesthetic performance of the object of the project, but also in the background we introduce a lot of new technology into the local culture. And also Philip Wurzpan, who is the former dean of ETH, and he also talked about writing some comments to my project, Matter and Mind. So it's not only just a new making process of the material and the matter, the material performance, but also we set up a lot of relation to the mind, to the culture, to the understanding between the material and the local culture. So I want to introduce several projects on that. This is Zhishe we constructed in 2016. So this is a super small project, only around 200 square meters. We constructed everything around like 2.5 months. So every pieces of brick was like parametric design in the process, and also we collaborating robotics to fabricate the wall. The wall was fabricated in 1 month. You can see this kind of curvature is showing like a cantilever entrance of the building. Every brick was designed and put them into the robotics, and which is every brick have their parameter of their location. So which is the location of each pieces of the brick actually, which based on the material performance and structural performance analysis, including the wind load, stress, and displacement, and we integrate them and translate the kind of grayness and color grayness into the location of each brick, and we delete some brick on the top of it, and we have a cantilever curvature in the entrance of this building. So you can see we have some quality of this curvature, but all the bricks was recycled because which is a industrial area. We're collecting the bricks from the teardown project, and select the one not broken. And we just try to set up a relationship between the roughness and the accurate location of the brick. We put the sensors, 3 different sensors on the top of the robot effector, and we can figure out the geometry center of the brick. So we control the geometry center, but actually the shape of the brick is not very accurate because which is recycled bricks. But you can see this kind of very interesting quality which produced by the machine and which collaborating between the machine and the human. The interior space is we introduce light into the main wall, natural light, and which is very small, just 1 room exhibition gallery. But the people like it very much, which is located in Shanghai. The second project is designed in 2015, Fab-Union space, which is located also on the westbound of Shanghai by concrete. We change another material. So the span of this building is like 14, 15 meters. And we try to create 2 very high space, like 5 meters, 5 and 3, like 3.3 meters. So it's totally 10 meters. So it's 3 floors, 2 floors. And we don't want to put the column in the middle, but as you know, if we want to create some concrete structure, it's impossible for like 14, 15 meter span. So we try to introduce a stair in the middle, which not only circulation space, but also structure space. So the concept is coming from the optimization, the simulation optimization by the structure performance. And we try to translate this kind of performance into the fabrication process and try to produce a new space, new experience of the space. So this is like the circulation design. We try to connect this 2 height space and make an interesting circulation, which is like you go inside the wraps of concrete and go coming and going outside and going to the 2nd floor, which is totally dark and light and different kind of experience inside this building. And the whole design process is actually based on the circulation. And then we firstly thinking of them is all solid by concrete. And then we optimize this by the finite element optimization tools. At that time, we use Milipadi to delete the unused useful material and generation by generation to the like 80 steps iteration. And then we polish the surface by the rule surface, and then to translate this optimization to a spatial space. So the right diagram is simulated by the traditional software. You can see the structure performance is very good by this optimization tools. So the right one is done by the traditional local LDI structure engineer, and then the left one actually is the architects. We implement the new plugin tools, Milipadi, to optimize this geometry form, which is like 6 years ago. And also it's a real project. It's not just a design studio project. And after we make the drawing, we find it's extremely difficult to translate this kind of section joints and how to construct it. It's impossible for the workers to understand these kind of sections. So we make different scale models and try to teach and think about how to construct this geometry. It's super difficult to locate each line, which is spatially, which is super difficult to positioning this kind of point and geometry. But this building actually was constructed in 4 months, which is extremely fast. And we have some special digital fabrication tools and to help us to address all this geometry in the construction process. So we fabricate all the panel, which is we use the timber panel to generate the mold. And this panel, because it's not 100% roof surface, actually 80% roof surface, but 20% double curvature. So we need to unfolding this kind of mold, and we fabricate by the robotics timber panel and put them precisely to make the form finding of the mold, collaborating with the workers in a very short time to construct is a very complicated geometry in a short time. You can see the plan, and without column in the middle, it's all the diagonal concrete wall. The wall is not wall, the wall is folding actually in the space. It's uncertain and the force flowing setup, making a new aesthetics performance, which is totally based on structure simulation, structure optimization, design softwares and design tools. So you can see the inside experience after construction, the wall is actually folding. So it's really difficult to define how the force is flowing in this space, how to support this space. And the inside of the space is the stairs, which is hidden in the middle. So this is a integration of architecture design and structure design, structure performance, structure engineering design. So it create a very special experience of the space. So this is second floor. You can see the stairs leading you to the top of the roof. And this is the stairs from outside second floor to the third floor. And also you can see the light washing the concrete here, and which is a parallel light from the window. And although the space is really small, I told you around 50 meters, but the light wash the concrete and showing the volume of these stairs, which give us really special geometrical experience because of the geometry from my form finding process. And we invite some dancer to make a performance in this building, and also different exhibition here, some art events happening in this space. This is furniture exhibition. Okay, and robotic carpenter. And last one is concrete and brick mansion, and we come to the robotic carpentry, which is also culture-oriented wood structure design and fabrication. So in our design, it's important to embracing not only the performance-based formation, but also the crafts, the new crafts we develop. That is the fabrication to deploy the new tools easily or efficiently fabricate this high performance form. So this is the timber project we designed and developed in last year, the beginning of 2020, before the COVID, in Shenzhen, and win the academic award of the Shenzhen Biennale. So which is showing nomadic wood process. The first is geometry form finding. So normally the timber are straight, right? We'll try to challenge if the timber could be like curvature. So we develop geometry and define them component by component. And the most difficult is how to fabricate them. So we implemented the laminate wood and like two robotics, like two hands of the human body. One is milling, one is sewing. This is the laminate process for the material. So this laminate would make the one curvature firstly. But every component is two curvature, double curvature. So the seventh curvature is cutting by the robotics. This is a round saw we developed. The joint is actually learning from the Chinese furniture in Ming Dynasty. It's really easy, but very strong, just like one detail solve all the problems of connections. Okay, that is pavilion.
我找不到你要搜索的内容。
Sorry. So after that kind of research, I want to introduce some real project based on the same technology, but we go to some rural area of China. This is in Bamboo Countryside Community Center we designed and construct 2017. So the site located in the rural area of west-south part of China, Chengdu, which is extremely beautiful area in China, hilly screen arrays, and the very close in relation between the human and nature. So this is the general site plan, which is a very traditional community, but actually because more and more young generation move into the big city. So the village is shrinking very fast in the past 10 years. So why the villager director invite me to design the project, try to stimulate, attract people coming back. So in the past several years, we design and construct like 6 buildings inside this village, and totally change in the life of this small town, because more and more people was attracted by the new lifestyle and new buildings and the new culture of the architecture based on this project. So we bring this project to Venice Biennale in 2018. So this is the village. So this is construction process. Actually, we introduced the timber structure and steel structure to generate like a double circle loop, which is a high double curvature roof geometry system. And also we're collaborating with some local bamboo craftsmen, and they help us to design and fabricate the facade. So which located very traditional area, including 8 different B&B hotel, and which is a public building also inside the village. So this is after the construction. You can see this community center actually, which have like a conference center and also and the information center for people to enter into the small town. And also, this is a model we bring to Venice Biennale. Right now, this model was collected by the M+ Art Museum in Hong Kong. So we're showing our technology how to fabricate this roof in a very short time. Actually, the on-site work is only 48 days because everything was prefabricated in Shanghai. We transport all the components by 6 big trucks to the site, and the workers just put them together by the timber and also steel structures. So this is the architectonics analysis showing column, beams, and the roofs, small beams and the tiles. And from the bottom, you can see the whole geometry here. And the details is actually very complicated because of the double curvature. We have different kind of section, and all the joints actually is different. And how to precisely fabricate these joints is really a challenge. So we implement the robotics actually, which can passing through 2 times of the timber and once of the steel panel, so we can accurately fabricate all these joints in a super efficient way. And also this is showing the digital twin, and the right one is a simulation, the left one is a fabrication process, and accurately for some curvature beam. And also all the detail drawing is not, we have no fabricator doing this, it's all the architects here in-house in Archi-Union to produce all this kind of scriptings. We're sending them to the factory by FU robot, as we developed in the past 6-5 years. And based on this kind of process, we're talking about, we totally redefining the design and fabricating process. So we totally redefine the industry, how to construct a building. So in the future, the design office we try to challenge is not just a design office, but also we can directly connecting the designers and the fabricators, because the fabricator is not a human, but could be like robotics. So which save a lot of time to working with the consultant to help you to calculate, to doing the detail work, because it very easily just based on the software and the factors we develop in our office. And after construction, you see which is quite close to the nostalgia situation of the local culture, but actually we name it as kind of non-local locality. The non-local part is the global platform toolbox we develop and which introduce them to the local culture. So the material and the form actually have a very strong relation to the tradition, but actually it's not a real tradition. It's not a real locality. It's kind of non-local locality, which collaborating in between the modern, contemporary, and the tradition. So we name it like the digital nostalgias or digital regionalism, what we're doing in the past few years. So you can see the building, and also some ornament on the facade is handmade by the local villagers, because the village is famous for the bamboo technology. So it's like some weaving bamboo, we put them on the facade. Interior space is very, we name it like the authentics of construction, because no decoration, everything is structure itself. Just present everything by the real structure. So you can see the allotments and people still planting different kind of vegetables inside this special courtyard. And different season, people planting different kind of vegetables or different wheat inside this scenario, this surrounding area. And also the B&B, very close to the community center and attracting a lot of people to experience its very special, unique space we produce. So you can see this kind of double curvature roof, and which also constructed in a very short time. And the interior experience is very special. You can see the roof beam and people embracing the trees, and also some lotus pond inside it. So another project is actually introduced MIT Tongji workshop 2019. Both Philip Rock and me was invited as visiting professor teaching in MIT, and also we invited the MIT student not only just studying in Boston, but also visiting Switzerland and Shanghai. We set up like a workshop, and finally we constructed this pavilion in Shanghai. There's Philip Rock and me standing on this special form. So the whole form was generated by Renovault, which developed by Philip Rock, who is famous for that. But I try to challenge, because all this kind of Renovault, the construction process wastes a lot of material. We need to use timber to construct the scaffoldings, which is quite a lot, waste a lot of material to generate a form. But this time we try to use the 3D recycled plastic, PLA, to print all the mold, which we spend only 8 hours on site. to generate the form precisely, accurately construct bricks. So that is the collaborating between Philip Rock and my team. And we're teaching the student in 3 weeks, including some traveling and fabricate this whole purpose. This is a performance we make research because different geometry will have different folding performance. And this, which is really stiff, and student can even sitting on it. So the generating process is very fast, as I mentioned, and very accurate and save a lot of material. And this kind of PLA could be recycled after the formation process. And 3 layers of raised bricks was constructed. This is different perspective showing the process. And finally, we would take away this mold and the structure is coming out. So that is what we're showing here. And this is a project we named Red Pavilion. And after 6 months of that teaching process, we introduced this technology in a real project. The span of this one is 45 meters, 3 layers of bricks. So the thickness of it is, the proportion is 1 to 300, which is like even thinner than the X shell. So that is also a special scenario I want to introduce here. You can see. Okay, we have a video. So the mold is printed by PLA plastic, and also the insulation layer was spraying on it. So this is a permanent building. So we on-site fabricate all components by reciprocal structure components by the insulation on it. And the formation is extremely fast in several days. The total project was finished in 1.5 months of this one, on-site work. The regulation is not supported. So we use the real load test on the real project. It's like 50 tons, like 400 people standing on it to test if it's safe or not. This is a final object, which is people can twisting, working on it, and seeing all the project in the surroundings. Okay, another project I want to show is during the COVID. Last year, the world is shutting down, closed down, including Shanghai, but still the client in Nanjing, which is like 300 kilo away from Shanghai, they want to construct the main gate of the theme park, because they want to open in a short time. But during the COVID, no one can finish this project. But we actually invite 12 robotics collaborating with the office, printing out the project in 4 months and fabricate them in a very short time. So this is the main gate of the theme park. So ultimately, this is a real photo, it's not a modeling. You can see all the components is double curvature, is no 2 components same to each other, but everything is custom printed by the robotics. This is on-site construction process. You can see the light, the geometry, the entrance. So this is showing, because the designers stay at home, and only 3 people control robotics in the robotic factory. 3 people control 12 robotics, print all the panels. And one of our team members is in Malaysia, which is super far away from Shanghai, but we set up a new model of working because people can send the files to the factory, and the toolbox and which by the FE robot and the factors we developed in the past. So we can control the robotics in super fab, which is like a cloud controlling process for the whole construction. And the components we're showing around 1,500 components. And we have a steel structure in the middle. So this is the multi-layers, how to construct this special structure in 4 months. And also we have another pavilion, which locates very close to that main gate. So this is the basement entrance for the same project. We use timber structure, which is also double curvature we're showing. And also we use some TPFE to cover on the top of it. So you can see this vector geometry. It's different double curvature showing the light, and people can walk through this large scale pavilion. Another project we implement, only one technology, is actually including the prefab timber, brick mansion, 3D printing, but it's really like embracing the nostalgia's culture in Sichuan and Chengdu province. And this project we're going to Venice Biennale this year. We'll present in China Pavilion in Venice, which is located in the middle of nowhere actually, because it's like the bamboo forest and the farming land, which in the rural area of Sichuan province. And the people also planting here. So the bricks was fabricated by the brick mansion robotics and the timber structure roof. Because of the earthquake, the structure is really difficult, but we try to make it kind of transparent in the middle, and the top is the roof, the water falling down and showing the elegant entrance, embracing the people into the space. In different time, showing different kind of experience. And also the wall was 3D printed by the plastic, and including the furniture is also 3D by the robotic printing by the robotics. So this is a video showing the project. The robotic fabrication makes very high, elegant accuracy. This project was finished, on-site work is only for 58 days, super fast, but it's very accurate. And we not demolish the farming land because everything is prefabricated, which have a very small influence to the environment. So I invite Philip Block and Liu Jiakun, a lot of very interesting architects in China to visit, and we have a different talks and events here in this building. Okay. How long? How many? Maybe 2 more projects. This is in Wuzhen Internet conference. And phase 1 was designed by Wang Shu, and we designed phase 2. And this project was finished, including design, 6 months and a half, 30,000 square meters. This is Old Town. You can see the relationship between them. So this is structure, performance, form finding, and optimization process. The main beam system. And structure separate the spatial hierarchy by the support big beam. And also we have semi-outdoor space and main outdoor space. The most challenge is hanging cables, hanging steel beams, which is fabricated by the robotic welding system. Because every curvature is different. Every beam have a different curvature. And also have some wind cable to control its stability of the buildings. So this is after construction. You can see the ripple facade. Actually, we fabricate pieces by pieces. Every piece is different. You can show in this kind of flowing aesthetics performance we produce by the fabrication technology. And also reflection of water and also semi-open space here in between this double layers facade. So this is a construction process. With no scaffolding, more than 40 cranes and robotics on site. We collaborating with China Construction Group to develop a lot of different kind of process, very interesting to construct the whole projects. You can see the 6.5 months project have very high quality of details. An interior space with no decoration, everything is structure itself, and which is the architectonic we want to introduce. And this is a machine for welding the hanging beam. We have six machine, and the fabricator fabricate all the beams in 3.5 months for this project, which extremely control the timeline of the project. So we collaborating with China Construction Group, not only in this project, but also in another project in Shanghai, which is the artificial intelligence tower, which is also double curvature curtain wall system, also implement this machine. So the designer here is not only design the form of the building, but also we design the tools, how to fabricate the buildings. So you can see the quality of this curvature roof beam, which is like we name as the hanging culture beam. Yeah, every curvature is different because the roof is like a double curvature roof system. So we can very accurately fabricate them. And also we teach the industry how to optimize their version of construction in the project during after we set up this project. This is we already introduced. Also, we 3D printing a Starbucks coffee inside this campus. And also we have another water pavilion, but actually which made by the brick. See it. So this pavilion was finished in 11 days, so super fast, but very interesting about the details. You can see the quality of this kind of rippling bricks. And aesthetics performance here is produced not by human, but by machine. So I think robotics not only fabricate replace the human labor, but also can produce different kind of quality and different kind of performance, not only on aesthetics, but also by the structure optimization design process. Final but not least is just finished project 2021. And then next Monday, I will participate in the opening of the project. So I want to introduce you, which is a hotel located in front of the cliff and the water pond. Extremely beautiful area. The entrance is like this, a big tree we plant to embracing the people entering to the hotel. And also we use the cable to hanging the timber roof and also the bricks as a facade fabricated by robotics. So you can see the quality and also the design process. So the site is located by, we use the drone to scanning the geometry of the land, and also by GIS software to translate this kind of files to the geometry system, and try to find the generate the geometry form by the understanding analysis of the GIS model, which is the very early version. The dark part is a cliff, beautiful cliff in the north part of the hotel. So which is a multi-agent based form finding process to understand the analysis and generate the form of the geometry. And because the height difference from the lower floor to the higher floor is around 14 meters. So it's not a flat site, which is like 3-4 stories height different. But we generate the form by this kind of local geometry of the site and put a continued roof on it by timber structure on top of it. And then generate the main space for the entrance of the lobby of the hotel. This is a formation process for the main space. To generate not only by structure performance, but also by inviting the light, introduce the light into the lobby, natural light. And the mechanical will help us to generate this kind of structure performance based timber support structure system and integrate with the roof system. And the cable hanging, because it's super big span, like 30 meters, no column, by the cable hanging the timber structure on top of it. So this is the project after finished construction recently. The digital fabrication wall by robotics. Okay, this is a brand new project I first introduced in the public. So this is a design process, optimization process to generate the main space. This is after construction. So we designed the architecture part. The interior designer is not from my office, so we're not very satisfied by this kind of details, but it's okay. The main space is key. The most part I like best is about, because the cliff is sitting back of this project. So it's kind of dialogue of bricks mentioned. It's a dialogue to the tradition environment, the local environment. So the process is totally fabricated by the robotics. Okay, last but not least, to introduce our event and also professors here and also participate 2020 DigitalFUTURES. I think DigitalFUTURES is a platform to help us to invite all the academic researchers and educators and students, which is a platform for people to learning from each other. So we make a huge progress in the past 10 years because we're learning from the world, and also a lot of our friends is from friends here, from PhD student to be the very prominent professors globally. I think DigitalFUTURES is something we believe is a learning platform because we're opening our platform to the public and we're learning the new technology from the others. So that is some new culture we want to set up. So you can see the application people from the very beginning, only 30 people participate this workshop. But last year, you can see more than around 9,000 applicants to participate in the future. And a lot of educators from the world, you can see different continent, and have different people participate, including Africa, including Australia, Europe, the States. And also the partner, global partner from Europe, a lot of very good university participate. In the States also have a lot of partners. So it's like we open everything to the public, and also we are looking for the learning from all the researchers around the world. So that is a lot of very important figure around the world to join us in the past few years. I would like to show a lot of thanks to all of them. And also more and more young generation actually participate through this platform. So thanks a lot for the invitation. Hope it's not too long for you. It's a great honor. And if you have any question, I would like to make some discussion with all you guys. Thank you. Thanks a lot.